Hello everyone, and this is my channel where I upload videos regarding CSIR NET. So if you haven't subscribed to my channel yet, then quickly do subscribe for getting all the updates. And hit the bell icon for getting all the notifications. So let us get back to our topic, that is matrix inverses. Okay, an n cross n matrix A is invertible or non-singular if there exists another n cross n matrix B called the inverse of A such that AB is equals to BA is equals to IN. IN is what? So IN here, IN indicates the identity matrix of order n cross n. Okay, so the inverse of A is denoted by A inverse. If no such B exists, A is not invertible or singular. Okay, so here singular means the determinant of A will be equals to 0. Okay, and if the matrix is non-singular, that means the determinant of that matrix is not equals to 0. Okay, when a linear system AX is equals to B has an invertible coefficient matrix A, it has a unique solution. Okay, so about this I'll be discussing in the system of linear equations. Okay, so till then just remember these points. Okay, now see, here are some points to remember. Okay, now if A belongs to if n cross n is invertible, then its inverse is unique. Now here f n cross n is the set of all n cross n matrices over the field F. Okay, so if A is a n cross n matrix which is invertible, invertible means whose inverse exists. Okay, so that means whose inverse exists, that is A inverse exists, then its inverse is unique. And any matrix is invertible if and only if its determinant is not equals to 0. And the determinant of a matrix is not equals to 0, then it is called a non-singular matrix. Okay, now next point, if A belongs to f n cross n is invertible, then A inverse is also invertible and A inverse is equals to A. So here it's saying if A is a n cross n matrix which is invertible, then A inverse is also invertible. That is, the inverse of A inverse is equals to A. Okay, now see, the next point is if A is a n cross n matrix which is invertible, then its transpose is also invertible. Okay, here this is will be here. Okay, then A transpose is also invertible and A transpose inverse is equals to A inverse transpose. Okay, so let me prove this through an example. So let us take an example. Okay, example A. So let A be a 2 cross 2 matrix, okay, which is equals to 7, 3, 2, 1. Okay, now we will check whether this property satisfies or not. This one, that is A transpose inverse is equals to A inverse transpose. Okay, so here see, let me write that property. AT inverse is equals to A inverse transpose. Alright, so now we will find its inverse. So here, okay, see, so the formula for A inverse is 1 by determinant of A into adjugate of A, isn't it? If A is equals to A, B, C, D, then the determinant of A is equals to AD minus BC. Okay, AD minus BC for a 2 cross 2 matrix only. Okay, for 3 cross 3 matrix again the formula is different, and this determinant of A is also denoted by like this. Okay, so here the determinant of A is how much? This is 7 into 1 minus 3 into 2, 6 into the adjugate of A. Okay, So for finding A11 here, the first element before this, we will have a plus sign, and for finding the first element, we will hide the first row and the first column. Then we are getting what? 1. So here we will have 1. Now for finding this element, that is A12 first row second column element, we will hide this first row and second column. Then we will get 2. Okay, so this is minus 2. In the second, here the sign will be plus, here it will be minus, and then again here it will be minus, and here it will be plus. Okay, now for finding now for finding A21 element, that is means this element, we will hide second row and first column. Okay, then we will get 3. So here we will have 3. And for finding A22 element, okay, this element, we will hide second row and second column. Okay, then we will get what? 7. So this is 7. And now we will find its transpose. So this is equals to 1 by 1 into, this is 1 minus 3, and this is minus 2, 7. Okay. While applying transpose, the column will change to row. Okay, and row will change to column. See, so this is what we got. Okay, so this is A inverse. All right, so instead of using this classical method, we can also use a short trick. So for finding the inverse of a 2 cross 2 matrix, there is a shortcut, that is, see, A inverse is equals to 1 by AD minus BC into, see here this 7 and 1 will interchange, so that is 1 and 7 over here, and before 2 and 3 we will have a minus sign, so that is minus 2 and minus 3. Okay, so this is equals to 1 by, this is AD minus BC, that is 7 minus 6, 1, and this is 1 minus 2 minus 3, 7. Okay, see, we got the same thing. Either you use the classical method or you use the short trick. Both will give you the same thing, but this will give you the answer in lesser time. Yeah, so if you want the formula for this, then see, if A is a 2 cross 2 matrix, okay, where A is equals to A, B, C, D, then the inverse for a 2 cross 2 matrix is given by 1 by AD minus BC, which is the determinant of it, into this. Here, see, this A and D will interchange. Okay, so here we will have D and here we will have A. Okay, and then before C and B we will have a minus sign. So here we will have minus C and here minus B. So this is the shortcut formula for finding the inverse of a 2 cross 2 matrix. Okay, so now let us get back to what we need to prove. So this is the inverse that we got, and this is the original matrix. Now we will find the transpose of the inverse. So see, we got A inverse is equals to how much? This is 1 minus 3 minus 2, 7. 1 minus 3 minus 2, 7. Okay. So now A inverse transpose is equals to 1 minus 2 minus 3, 7. Alright. And now we will find A transpose inverse. Okay. So A is 7, 3, 2, 1. A is equals to 7, 3, 2, 1. Alright, now its transpose is equals to 7, 2, 3, 1, and the inverse of the transpose is the transpose inverse is equals to 1 by 7 minus 6. See, this is 7 into 1 minus 3 into 2, that is 7 minus 6, which is equals to 1. Okay, into here this will be, see, this 2 will interchange. Okay, the 7 and 1 will interchange, so we will have 1 over here and 7 over here, and we will have minus sign before 3 and 2. So we will have here minus 2 and here minus 3. Okay, so this is the inverse. Alright, and now from this you can see that this is equals to this, isn't it? So as the transpose of the inverse is equals to the inverse of the transpose, so here this result is proved. Okay, this is proved. So we got the third result. Now the next result is, if A belongs to Fn cross n is invertible, then for each B belonging to Fn cross 1, Ax is equals to B has a unique solution, and it is x is equals to A inverse B. Okay, so here Fn cross 1, B belongs to Fn cross 1 means, see, B is a matrix which belongs to Fn cross 1 means B will be such type of matrix, that is column matrix. Okay, next point is, if A belongs to Fn cross n, that is if n is a n cross n matrix, and there exists C belonging to Fn cross n such that either A into C is equals to identity matrix of n order, or C into A is equals to identity matrix of n order, then A is invertible and A inverse is equals to C. Okay, that is a left or right inverse for a square matrix is actually its unique two-sided inverse. Okay, now the next point is, for any n, the identity matrix In is invertible and it is its own inverse. Okay, and if P is a permutation matrix, then it is invertible and P inverse is equals to P transpose. Okay, now let me prove this with the help of an example. So now let us take a permutation matrix, say this one. Okay, here this is a permutation matrix because here each element of P is either 0 or 1, and the sum of each row and column is equals to 1. See, the sum of each row is equals to 1 and the sum of each column is also equals to 1. Okay, so this is a permutation matrix. So here we need to prove that P transpose is equals to P inverse. Okay, so this is what we need to prove. Alright, so let me erase this one. Yeah, so now let us see the answer. So first we will find the inverse of P. Okay, so P inverse is equals to 1 by determinant of P into the adjugate of P. Okay, so first let us find the determinant of P. We can find the determinant of P by picking up any row or column. So let us take the first row. So we will get this as 0 into, okay, see, hide the first row and first column, then you will get this as 0, 0, 1, 0. Okay, now minus 0 into, hide the first row and second column, then we will get this as 1, 0, 0, 0. Okay, then plus 1 into, hide the first row and third column, so this will be 1, 0, 0, 1. Okay, see, the first two elements will be 0 because 0 into anything will give 0. Okay, so we will get the value of only the last element, that is 1 into its determinant, that is 1 into 1 minus 0. So this is 1. Okay, so we got the determinant of P to be 1. Alright. So now let us find the adjugate of P. Okay. So here P is equals to 0, 0, 1, 1, 0, 0 and 0, 1, 0. Okay. So the adjugate of P is equals to, first we will assign the sign to each element, that is plus, minus, plus. This is minus, plus, minus and plus, minus, plus. Okay. And then we will find the minors, that is A11, A12, A13, A21, A22, A23 and A31, A32 and A33. Okay. And after that we will do its transpose. Okay. So let us do this. Now let us find first A11. So A11 is equals to, hide the first row and first column, then you will get this as 0, 1, 0, 0 and its determinant is, see, 0 minus 0, that is 0. Okay. Next let us find the minor of A12, okay, which is equals to, hide the first row and second column, then you will get this as 1, 0, 0, 0 and its determinant is equals to 0. Next let us find A13, which is equals to, hide the first row and third column, then you will get this as 1, 0, 0, 1 and its determinant is 1 minus 0, see, 1 into 1 minus 0 into 0, so this is 1. Next let us find the determinant of, now next let us find the minor of A21, which is equals to, hide the second row and first column, okay, then you will get this as 0, 1, 1, 0. So its determinant is 0 minus 1, which is equals to minus 1. Next let us find for A22, hide second row and second column, then we will get this as 0, 0, 1, 0. Okay. So this is equals to 0. Its determinant is also equals to 0. Okay. So now let us find for A23. Now hide second row and third column. Okay. Then you will get this as 0, 0, 0, 1. Okay. And its determinant is equals to 0. Okay. Now next let us find A31, which is equals to, hide the third row and first column, then you will get 0, 0, 1, 0 and its determinant is equals to 0. Next let us find for A32, which is equals to, hide the third row and second column, then you will get this as 0, 1, 1, 0. So this is 0 minus 1 and its value is minus 1. Next A33. A33 is equals to, hide the third row and third column. So we will get this as 0, 0, 1, 0 and its determinant is also equals to 0. Okay. Now we will substitute the value of all these minors into this. Okay. And then we will do its transpose to get adjugate of P. So now adjugate of P is equals to, this is, first let me put the sign, that is plus, minus, plus, this is minus, plus, minus and this is plus, minus, plus. Okay. Now A11. A11's value is how much? 0. See. So this is 0. Then A12. A12 is also is equals to 0. Okay. So this is also 0. Then A13 is 1. Okay. So this is 1. Alright. Now next A21. So A21 is how much? A21 is minus 1. So this is minus of minus 1. Alright. Then A22 is 0 and A23 is also 0. So this is 0 and this is also 0. Next, let us see what is A31. A31 is 0 and A32 is minus 1. So this is 0 and this is minus 1, and A33 is also equals to 0. Okay. So this is also equals to 0. Now do its transpose, which will give us, see, this is 0, 1, 0. This is 0, 0, 1, and this is 1, 0, 0. Okay. So this is the adjugate of P. And the inverse of P is equals to 1 by determinant of P. Determinant of P, we got the determinant of P to be 1. See, 1. So this is 1 by 1 into adjugate of P, that is this one, 0, 0, 1, 1, 0, 0, 0, 1, 0, which will give us what? The same, this 0, 0, 1, 1, 0, 0 and 0, 1, 0. Okay. So we got this as P inverse, and now let us find the P transpose. Okay. So yeah, we know that P is equals to 1, 0, 0, sorry, 0, 0, 1, 1, 0, 0 and 0, 1, 0, isn't it? Well, let me check this. So now we will find its transpose. So P transpose is equals to how much? 0, 1, 0, 0, 0, 1 and 1, 0, 0. Okay, so we can see that P transpose is equals to P inverse. Okay, so therefore P transpose is equals to P inverse, and our this result is proved. Okay, see here, if P is a permutation matrix, then if P is a permutation matrix which is invertible, then P inverse is equals to P transpose. Okay, so we have proved this. So this was all for today, and if you liked my video, then please do like, share and subscribe to my channel. And thanks for watching. Bye bye.